Hi, in this one I'll be taking the second example for hyperbolic function. I did a video for Laplace transform of cos 80. You can look at that one in this same playlist. So in this one we are finding the Laplace transform of sin 80. So we learned that the Laplace transform of a function f of t is given as 0 to infinity f of t times e minus st dt. And we integrate the function. Okay, so we know that in hyperbolic functions, sin at equal to e to the power at minus e to the power minus at, all out of 2. Or you can factorize the 2 out, making 1 out of 2 EAT minus E minus AT. Okay, so we can substitute this. Any of them is correct. So let's substitute this one into the function to replace sin AT. So before that, let me put in sin AT. Okay, so now when we substitute this one, we are having integral from 0 to infinity 1 out of 2 into bracket EAT minus E minus AT times E minus ST dt. Okay, so from here we can factorize this 1 over 2 out by having 1 out of 2 integral of 0 to infinity EAT minus E minus AT E minus ST dt. We expand by removing brackets, use this to multiply, use this to multiply. So we have 1 out of 2 integral from 0 to infinity. This time this, we have E minus ST times this is giving us EAT minus E minus ST times E minus AT, all multiplied by dt. Okay, so from there we can now work on the powers of E and then work on the powers of E of this side. So this is the same as 1 out of 2 integral of 0 to infinity. We have E, so we have our S. Now t is common, we are factorizing it out. We have s here, which is negative, so let me put this in brackets. We have minus outside minus a, you close it, times t, so that this time this will give you minus st, this time this will give you plus at for this function. Okay, so we have minus, we do the same process here, e minus outside, we have s, but watch this carefully, this is negative a, so I'll have to put plus a here, so that this time this will give us negative st, this time this will give us negative at. Multiply this result by dt. Okay, so now we are going to integrate the function and substitute the upper and lower limit. Now to do that, if this is your first time watching this, then if we have an exponential function e to the power at, then the integral of this is 1 over a e to the power at, or the same as e to the power at over a. So if I put a value here, coefficient here, any number here, then if I have e to the power minus 3t, then the integral of this is giving us 1 over negative 3 e to the power minus 3t. Now the function, we have minus s minus a as our coefficients of t, so we repeat the same process there, e minus s minus a times t. So the integral of this is going to give us 1 over negative s minus a, whatever that is, multiplying the variable t, then we raise to the same power minus s minus a times t. Okay, now from here you can rewrite this thing as e to the power negative s minus a t, or dividing negative s minus a. I chose this one. Okay, so we apply that process here. That is how you integrate an exponential function. Now, if we integrate this side, we have to integrate this side too. And we introduce our lower and upper limit. So we have 1 out of 2. Let's bring a square bracket. We integrate this one, 1 over minus s minus a, multiply by e to the same exponent, s minus at. Okay, then minus, we integrate this one, we have 1 over negative s plus a, close bracket, e to the same exponent, s plus at. Let's close the brackets, introduce your lower and upper limit. I guess you got that. From here, we are going to substitute our upper and lower limit to replace t. Remember that t is a real number between 0 to infinity. So this is equal to t, this is equal to t. I don't want to represent this with a variable and take the limit, so I just want to substitute them inside. Okay, so now we have a 1 out of 2. Let's bring a curly bracket, and then we open a square bracket and introduce the upper limit. So the upper limit, we have 1 over minus s minus a. This is not part. We have e minus s minus a. Wherever you see t, put in the upper limit. So into infinity. We do the same thing for this side. Minus, remember that negative times negative will give us plus. So I'll just put plus 1 over s plus a. E minus s plus a. I'll substitute my infinity. I close this one. Now it is always upper limit minus lower limit. So this is the upper limit. We have substituted that. So we subtract this result from the lower limit, which is 0. We fix 0 here. We repeat the same step. 1 over minus s minus a. E to the power negative s minus a into 0. Then this time this will give us plus. So plus 1 over s plus a, e to the exponent minus s plus a, and then you substitute your 0. You close this, then we close our curly bracket. Alright, so now from integration, we know that when we take the limit of e to the power, let's say, minus t or x, as t approaches infinity, this result is equal to 0. So once you substitute a very large number to represent infinity here, this result should give you 0. Okay, so you can test that on your calculator. So now from here, we have 0 here, 0 here. Now we have 1 out of 2 multiplying. Now watch very carefully. 0 will make this part of the function equal to 1. 1 times this will give us the same result. Remember that we have negative here. So this is my negative. That is what I have there. 1 over 2 is multiplying the whole bracket. So this side, we get rid of this side and we focus here. So 1 times this one will give us the same thing, minus s minus a. Then plus, this side is also 1. Multiplying this, giving us s plus a. Okay, so we can close this and we close our curly bracket. Now looking at this very carefully, you use this negative to open the brackets, which is the square bracket. So this time this time this. So let me put that result here. So we have 1 out of 2. Now this time this is giving us 1 over s minus a. Then this time this is giving us minus 1 over s plus a. Okay, so this is what we have. This is now very simple for us to solve. Your next step is to take LCM. So let me take the LCM here. LCM is s minus a times s plus a. So s minus a times s plus a. So now s minus a will cancel this. We are left with s plus a. Multiply it by 1. We have s plus a. Then minus, we have s plus a will cancel s plus a. We are left with s minus a. Multiply it by 1. You have s minus a. Okay, so you can close this and bring your 1 over 2. From here, we can expand this one by using this to open the bracket. So we have our 1 out of 2, s plus a. Negative time this is giving us minus s. Negative time this is giving us plus a. We divide this result by expand the denominator. S times s, you have s squared. s times a, you have plus as. Negative a times s, you have minus as. Negative a times a, you have minus a squared. You can close this. Now watch carefully. This and this are the same. This will now cancel. This and this are the same. This will now cancel, and we are left with what? 1 out of 2 into bracket. A and A will give us 2a divided by s squared minus a squared. This will now cancel this. You are left with 1. 1 times the bracket will give you the same result. So our final answer equal to a over s squared minus a squared. So therefore, the Laplace transform of sin at is equal to a over s squared minus a squared. Remember that a is a scalar representing any value. So when I put sine 2a here, this result will give us 2 over s squared minus 2 squared, giving you 2 over s squared minus 4 if a is representing a scalar. Alright, so thank you for joining me in this one. This is done. I'll see you in the next video.